Okay, so here's the summary for mole calculations. Let's follow along. So first, remember that metal is made up of particles, and these particles can be atoms, molecules, or ions, right? And we know that they are all very small and very light. And so how do we actually effectively measure and quantify the amount of substances? And so we have to make use of a counting unit known as a mole. So 1 mole of any substance is 6.02 times 10 to the power of 23 particles. So again, these particles can be atoms, molecules, or ions, and this is known as Avogadro's constant. This can be found in your periodic table, at the bottom of the periodic table. So there are four formulas for us to calculate the number of moles of a substance. But basically, we can calculate number of moles based on its mass. If it's a gas, then we can use its volume. And if it's a solution, we can look at their concentration. Okay, so mass. 1 mole of any substance will weigh its MR or AR in grams. And how do we calculate MR and AR? We need to look at its mass number. Okay, I don't have an example here, but let me try and bring out a periodic table. Periodic table. Okay, so what is atomic mass number? AR. Relative atomic mass, there's 2 numbers here, right? Let's look at sodium. There's 11 and there's 23. We know that 11 tells us the number of protons and 23 tells us the number of protons plus electrons. Protons plus neutrons. Okay, so this adds up to 23. And when we look at AR, we actually look at the larger number because we want to know how much it weighs. If you don't remember, look at the key. Okay, the key will tell you. Okay, going back to... wrong. Chemical calculations. So number of moles equals to mass over MR. To use this formula, we need the formula of the substance to find its AR, MR. So for example, if it's NaCl, I will need to sum up the ARs of these 2 elements, right? So sodium has a AR of 23 and chlorine is 35.5, and so the MR of NaCl would be 23 plus 35.5, that's 58.5. And we need the mass of the substance in gram. Okay, so if it gives you in kg or any other unit, convert it to gram first before we apply the formula. So what is AR and what's MR? We need to know the definition. Okay, this can come out in exam. How we calculate MR is we add up all the AR of the atoms in this molecule. Or if it's a relative formula mass, then we look at the mass of the ions in this formula. Then we look at volume of gas. So 1 mole of any gas at room temperature pressure occupies 24 dm3. So to find number of moles, we just need to take the volume of gas divided by 24 dm3. To use this formula, it needs to be a gas and it needs to be at RTP. So if the question didn't specify, we assume it to be at room temperature and pressure. Okay? And there's a volume of gas must be in dm3. So please convert. If it is in cm3, take note that 1000 cm3 equals to 1 dm3. So there's also this thing known as the volume ratio. If 2 gases share the same volume at the same temperature and pressure, they actually have the same number of moles of particles. So this was a simulation that was shown to you before. Hence, when comparing number of moles of gaseous reactants and products, we can use volume ratio instead of mole ratio. What do I mean? If I have 1 dm3 of H2 gas, I can say that it has the same number of moles. Let's call it N. Okay, I have N number of moles of H2 gas. It will be the same as 1 dm3 of oxygen gas. Okay, they'll both have N particles or N number of moles. Then let's look at concentration of solution. So what is concentration? Concentration is the amount of solute dissolved in a unit volume of solution. Now typically this unit volume is in dm3, And the amount can be taken in two ways, right? Amount, I can look at number of moles. Amount can also mean by mass. So that's why for concentration formula, there's actually two formula. Depends on what is the unit of concentration that the question is asking you for. Now, if the question doesn't specify, the default is to find in mole per dm cube. Okay, so mole per dm cube tells you is number of moles per dm cube or per volume of solution. And for you to find the other concentration formula, which is gram per dm cube, we know that the difference is actually converting from number of moles to mass. Okay, the per dm cube part is the same. So from moles to mass, we already know the formula, right? For number of moles, to get mass, I need to multiply by MRAR. For mass, to get number of moles, I need to divide by MRAR. Okay, so depending on what's the thing lah. To use this formula, you need it to be a solution. Okay, so for it to be a solution, it must have the state symbol AQ. The volume of solution should be in dm cube, and the concentration of solution must be given to you. Okay. Then next up, we talk about mole ratio. So what is mole ratio? So when we write a chemical equation, it must be balanced, first of all, so that mass is conserved, right? For reactants and products. So we look at a balanced chemical equation to deduce the ratio in which the number of moles of reactants will be used up and the number of moles of products will be formed. So if you look at this equation, we see that to balance the number of atoms on each side, I need to add a 2 in front of hydrogen and 2 in front of water. Okay, so 2 moles of H2 will react with 1 mole of O2 to give 2 moles of H2O. With that being said, if I only have 0.5 mole of H2 gas, how many moles of O2 would I be reacting with? Okay, because they have a 2:1 ratio, if I only have 0.5 mole of H2 gas, I will only use up 0.25 mole of O2 gas. So they are always existing in a 2:1 ratio. And what is a limiting reagent? Okay, a limiting reagent is what limits more product from being formed, and it will be fully used up in a reaction. Okay, so it will drop to 0 moles. This can be determined by finding the number of moles of both reactants, and then we compare them based on their mole ratio. Okay, so going back to this example, say hydrogen and oxygen gas is 2:1. What if I have 1 mole of H2 and I only have 1 mole of O2? In this case, which is limiting me from making more? Answer is H2. Why? Now, if I take this to be the, just analyze this. If I have 1 mole of H2 needs 0.5 mole of O2, I have more than enough, which means it is in excess. Okay, if I analyze it from another angle, I have 1 mole of O2. It needs 2 moles of H2 to react. I only have 1 mole. Okay, not enough. So this tells me that this is limiting. Okay, so either way, what we do is we just look at one of them first and we compare using the mole ratio. Do I have enough? Do I have more than enough? Okay. Now let's look at how do we apply mole calculation questions, right? So example, iron powder will burn in oxygen to produce iron 3 oxide Fe2O3. When 7.2 dm cube of oxygen gas reacts with iron, let's calculate the mass of Fe2O3 formed. Doxalize, there's no equation given, so that's step 0. If there's no equation given, you are supposed to write a balanced chemical equation. So let's annotate the question together. First, I have iron and I have oxygen, and this is the product. Okay, so first write down the formula, iron, oxygen, and the product. Then balance the equation. Okay, so you know that it's balanced already. 2 here, so I put a 2 in front. Sorry. Yeah, so it's balanced already lah. Okay, I will not go through how to balance this. Then we annotate the equation based on the info given. So the info given is 7.2 dm cube of oxygen, and I want to find the mass. Okay, so that's why I put down 7.2 above oxygen, and I put question mark mass for Fe2O3. So step 1, we find what's known, the number of moles of what's known. So it gave me the volume of a gas, right? So I can find the number of moles by applying the volume formula. Divide by 24 dm cube, I end up with number of moles. Now that I have the number of moles, I apply mole ratio to find the number of moles of the unknown that I'm interested to find out. So in this case, it will be between oxygen and iron 2O3. So since it's 0.3 mole for O2 and it's in a 3:2 ratio, 0.3 mole of O2 means it's 0.2 moles of Fe2O3. Then we apply whatever formula I need to find the quantity that is specified by the question. So the question asks for mass, so I need to use the mass formula. Okay, so mass formula is take the number of moles, multiply by the MR. Okay, and you end up with the answer in grams. So take note to also always write the units, because overall we can deduct 1 mark for not writing units lah. Okay, so that's it for mole calculations. Now, of course, there are other formulas like percentage mass, percentage purity, percentage yield, but all those percentages kind of questions are more or less quite straightforward. Take what's 100%, put it as the denominator lah, and times 100%. Okay, so those I leave you to discover on your own and revise on your own.